this theorem that says if A is less than B, which is less than C, so C is the longest side, and we have the lengths of the sides of a triangle, okay, if A squared plus B squared is less than C squared, we have an obtuse triangle. So that's this right here. So if you have A, B, C, this angle is greater than 90. Okay, and then here, if you have A, B, C, this angle is less than 90. So if A squared plus B squared is less than C squared, you have an obtuse angle. If A squared plus B squared is greater than C squared, then you have an acute triangle. And it's opposite. Like you think larger. Huh?
Is the greater symbol 90 or the 7?
Oh no, that's greater than 90 for obtuse angle.
What?
And that means it could be 91, right? It's just greater than, I mean, it could be 90.2. It's still going to be greater than 90. Here, this is going to be less than 90. It could be 89.9, but it's going to be less than 90. But it's kind of opposite because we think obtuse angle is larger than 90, but we have a less than here. And acute angle is less than 90, but we have a greater than here. So just be aware of that this symbol does not correspond to this definition. Like as far as this isn't less than, it's greater than, less than, right? Because this is less than 90. This is greater than 90. Does that make sense?
The one in the red is
the obtuse angle. Yeah, the obtuse. And the blue one is the acute. And this one's right. Okay, the converse of the Pythagorean says if the area of the square whose sides is a hypotenuse is equal to the sum of the area of the squares. Okay, basically it says if C squared is equal to A squared plus B squared, then the triangle is a right triangle. Okay, before we were saying if A squared plus B squared equaled C squared, or no, we were saying if we had a right triangle, then A squared plus B squared equals C squared. That was the Pythagorean theorem, right? If you have a right triangle, then you have this equation that works. Now we're saying if your sides equal this, if your sides do this equation, then you have a right triangle. Does that make sense? So we want to determine are 5, 7, and 9 an acute, obtuse, or right triangle. So what we do is we take 5 squared plus 7 squared and then 9 squared. So 25 plus 49 and then 81. $74, right? And 81. Then we figure out what symbol do we put here to make this true? Less than, right? Yeah. And if I use a less than symbol, is an obtuse triangle. The obtuse angle is greater than 90. See, that's why I said it's the opposite. I'm going to go back real quick. Here I have the angle. This angle is greater than 90, but A squared plus B squared is less than C squared. So it's like the opposite of what you would think. Yeah. So if this is a less than, you have an obtuse. If this is greater than, you have an acute. And if it's equal, so here we have A squared plus B squared less than C squared. Here we have A squared plus B squared greater than C squared, and here A squared plus B squared equals C squared. So if it's less than, that works, it's obtuse. Greater than is acute, equal to is right. We're going to classify this triangle as acute, obtuse, or right. So we're given these endpoints. And we need to find the lengths of the sides. Now, this side here, oh, this should be -4. Or no, that's +4. Okay, this side here is the length between the x's because the y didn't change, did it? So this side length here is easy. I just do 4 minus -4, so, or the distance between -4 and +4, it's 8. So this length is 8. Oops. Because if I go from -4 to 0, that's 4, right? And then from 0 to 4 is 4 more, so the length is 8. So this one's 8, this length. But now I'm going to have to find these lengths using the distance formula. Okay, so I'm going to start with this length here. So the distance is equal to the square root of 1 minus -4 squared plus 3 minus -1 squared So that's the square root of 41. And I'm just going to leave it as the square root of 41 because I'm just going to end up squaring it anyway, right? And then I find the distance between these points. And so I do 1 minus 4 squared plus 3 minus -1 squared. So I get -3 squared plus 4 squared. So I have the square root of 9 plus 16, which is the square root of 25, which is 5. So I have these three lengths, the square root of 41, 5, and 8. Now, I don't know what the square root of 41 is, so I'm just going to check that to see if it's less than 8. It's 6 point something, so it's less than 8. So these are A and B, that's C. So I say square root of 41 squared plus 5 squared and then 8 squared. So I have 41 plus 25 and 64. So 66 and 64. I'm going to put a greater than symbol here.
So it's acute?
So it is an acute triangle. And you can tell this is 66, this is 64. It's probably really close to being 90 degrees because these two numbers are really close to each other, but they're not. So it's acute still. Determine if these are acute, obtuse, or right. Can I have two sides be equal? Sure, right? I just can't have all three sides be equal. So 5 squared plus 5 squared and then 6 squared. So I have 25 plus 25 and 36. That's greater than, isn't it? So cute. I have 5 squared plus 12 squared and 13 squared. So I have 25, 144, and 169. This is equal. And if it's equal, it's a right triangle. So I have The square root of 3 squared plus the square root of 3 squared and then 3 squared. So this is 3 plus 3 and 9. 3 plus 3 is... If they're equal, yeah. So this one's less than, so that's obtuse. And then I have the square root of 3 squared plus the square root of 4 squared and then the square root of 7 squared. So I have 3 plus 4 and 7. That's equal. So it's right.